and we appear to be broadcasting on YouTube and recording our week every 2 weeks sync for IPLD, and it is the 15th of August, depending on where you are in the world. And we have a smallish crew today to look at what's happening in the IPLD world. So has anyone else put their stuff before me? No, it looks like I'm first. So I'm going to do an update first on IPLD. And I have done a lot of different stuff these past couple of weeks, ranging over a variety of things. So the thing that I spent probably the most time on, and that my first two items are related. There's a very obscure bug in this Filecoin deal-making apparatus where a car, for a Filecoin deal, a car is made twice. So it's made once to grab this comp, which is like, it's basically a hash of the car, and it's made again when it's received, or depending on how the flow works. There's these two places where cars are made, and the comp hash thing is compared between them. And there's this one component called Boost, which does a lot of this these days, that was coming up with these mismatching comps, and comp mismatches is basically a hash mismatch. The car that you gave me does not match the comp that you told me about, and they're very frustrating. And this bug has been showing up increasingly in this component, and getting more frequent apparently. No one can figure out what it is. So anyway, after lots of investigation, I found a really minor spec. A codec difference, and something that we never factored into the spec, the DAG-PB spec. And it's all to do with traversals and the way that, and Eric, you're gonna love this. It's all to do with traversals and the way that the data is instantiated into memory. So it turns out, so in DAG-PB, we have this links array, and the links array, when you encode by spec, you're supposed to sort it by the name field. So it's a bitewise sort on the name field when you sort it, when you encode it. And that's the spec thing. It's just, there's reasons why that might be nice, but it's not strictly required. It's just that all our codecs do that. So all our DAG-PBs, old and new, all do this sort thing, and it's a stable sort. And so if there's no string, or if there's different duplicate names, they just stay as they are and they go down. It turns out that Go Merkle DAG, our old DAG-PB handler, it also does a sort when it loads it from the bytes. But it does it in these really strange locations. So you can load it from the bytes, and then you've got this DAG-PB thing in memory, but it won't sort it until you make certain calls. So you make a call, suddenly your links are sorted, and you have your links. It shouldn't matter if codecs, when they're encoding, are sorting links. And so it doesn't matter most of the time. But now we have more and more codecs in the wild by third parties that are not quite doing the right thing. So turns out we have some major players that are storing stuff on Filecoin that are using their own codecs. There's a couple. One of them is written by somebody who's now on the stewards team, who's gone and fixed up his codec. Another one is by the ZAR working group. So ZAR has academic data. They've written a DAG-PB Python implementation, and it doesn't sort links when it goes out. And the reason why this matters is because this pathway through Go Merkle DAG is now invoked in one part of Boost. But most of the time that we create comp, we're using IPLD Prime selector engine. So there's these two different ways of traversing that should be the same, but for particular data where the links array is not sorted when it's encoded, when it gets loaded from disk and decoded using one path, the links will be sorted, and it'll traverse differently than using the other path. And so we get a car file with blocks that are out of order because the traversal is different. So yeah, and there's a bunch of other minor things in there. There's an investigation issue there if anyone's interested in this. But basically, when I'm having to update the DAG-PB spec to make this clear. I also have to write about the Go Merkle DAG differences with IPLD Prime, And there's some things to fix as well. But there was a little fix that was, just basically extracting the links list early in this traversal path before it gets sorted by some other code. That was the fix. So lots of fun with that one. But yeah, the joys of sorting. Anyway, the second thing I've been working on is this comes out of that same issue, which is trying to remove Go Merkle DAG as a path for Boost. Because one way to solve this is to stop using Go Merkle DAG. But it turns out that so Will had already did some work in the Go car library to do a for various reasons. We need a car writer that can skip a certain number of bytes at the beginning of the car before it starts writing out. And Will had started this. And so I picked it up during last week to try and finish it off. And I've got it mostly complete. And there's various constraints that it sort of has to live up to be able to replace what's in there now. But I've got it to the point where I'm starting to question whether it's even worth it, because the complexity, the sheer complexity of doing this with a selector, with an arbitrary selector, and having proper caching and being able to skip parts of the first part of the traversal and not touch the blocks door as much as possible. It's pretty insane how complex it gets, and I'm wondering whether it's worth baking that complexity into code. And so I've kind of put that on hold to think about it, and it may not actually get merged. Anyway, if anyone else is talking more about this, then yeah.
I guess I have a brief question, which is, so one thing I've noticed a little bit is that pathing with ADLs covers like a lot of what you might want with selectors. Not everything, right? Mostly the fact that like selectors define a language, and because I'm not transferring my ADL code around, you can run my selector stuff even when you don't have the ADL code I would have wished you had instead. Which we had some fun experience with when people were trying to use selectors to try and grab UnixFS data when there was no UnixFS ADL support inside of selectors, or there was no ADL support at all inside of selectors. And so I wonder, like, if you did this stuff on pathing instead of on selectors, if it would be easier, right? To some extent, a lot of the logic that lives in like Go Merkle DAG and Go IPLD format and whatever is path-based. And so it may be that trying to replicate that in like the IPLD prime world is like much easier, much more reasonable to do. If that makes sense. It just gives us like another way of describing subgraphs that's less powerful but easier for us to work with.
Sorry, before Eric gives a more comprehensive or interesting answer, I will say that my feelings on selectors are that we have these two modes that I don't think we're taking full advantage of. One is this mode of I want a full graph. I want an exhaustive, and that turns out to be the most common mode of using selectors, and yet most of the code that we write for selectors is taking into account the complex cases, and that's what I'm finding here. The requirement for this Go car thing, the immediate requirement is I just want an exhaustive selector. I just want to walk full graph, and yet I'm writing code that's trying to manage arbitrary selectors, and I don't even have a use case for arbitrary selectors, and so. It's like, okay, I could back up and just say this only does an exhaustive, and you can't even provide me with a selector, and then that brings up API discussions and all that sort of stuff. But even within the selector engine itself, we don't take this into account, because once we say I'm doing a full graph traversal, then so many things just disappear, and it becomes easy and straightforward. So that's my thought on that. But Eric, you were going to say something.
I agree. Selectors are wildly overcomplicated, and 99% of the uses can be handled by pathing alone. Especially, as Etienne was saying, now that we have the concept of ADLs. So like historically, selectors came up as a design idea and something we were going to try to build before we had the concept of ADLs. Chronologically, they were just first by like, I don't know, a month or two, maybe not even that much, but Okay, the oldest draft of selectors is like way older, but by the time I heard about it anyway. And yeah, pathing over ADLs is actually more powerful because it has the ability to do data-dependent things like understand the internals of sharding, which selectors still can't and never will. So yeah, if people want to build simpler APIs that explicitly talk about pathing and not selectors and say, hey, this covers a lot of use cases, see if you can get there. That sounds pretty good to me, honestly.
Yeah,
The amount of
it seems
sunk
like
costs on selectors is just, yep, it's a lot.
yeah, and that's what I was feeling with this Go car thing. I could get this to mergeability, but then like there'd be two people that would be able to maintain it in the future, and given enough time, I wouldn't be able to maintain it because I don't have the greatest memory, and so in a year's time, I'll look back in this code and say, what, and take a week to figure out what on earth it's doing, and then yeah. So, but it's almost like we have the most common operation is here's a route or here's a path to a route. Give me the full DAG underneath that route, and possibly it's the second one is here's a path, and I want that block, not the DAG. Maybe that's all we need.
Sometimes we have other ones like I want to get like effectively range requests, like I want this byte offset, like the things that have been added to selectors more recently, like I want to do an ADL thing and I want to have a slice inside the matcher. Those all came out of like use cases for it that we probably still need. I'll say like there's some good news and the good news and some bad news. The good news is that like if you wanted to start building APIs that take into account some of the pathing pieces, you could do them as like, but you didn't feel like either making up your own syntax or waiting around or like waiting for some like IPLD pathing syntax to emerge. You could just like use selectors as that syntax and then just verify that they fit the model, like they don't do anything weird when you get them. And so like that might be one way to like avoid a design discussion and get the thing you're going to faster. Because like I think what you're saying, like I totally agree with you. Like there's all these optimizations we can take when we allow ourselves a few of the easy paths, and the easy paths cover like a lot of stuff.
Yeah. Okay. I'm just going to quickly finish the rest of my update, and then I'll make a note here, and we can talk more about it at the end if we want. So some other stuff I've been doing is I finally went back and updated the JavaScript schema packages to the latest schema changes. There was a flurry of changes last year to the schema language and DMT that was super frustrating because it just sort of the internals just changed a lot. And so I put a big to-do in the JavaScript land, and I finally did that because I want to be able to use them with some stuff I want to build. So yeah, I updated that on the weekend, and we can now parse selectors and have the full DMT that's in the right format and all that sort of stuff. And there's also a validator as well. It's fairly simple. It's just I want to validate the blocks match a schema. As part of that, there's also a TypeScript schema, which is actually pretty nice to use when you're working with the schema DMT and you've got the TypeScript behind it telling you, there's this thing here, or this thing can't be here, or this thing is optional. They're actually pretty nice to use in an editor, and having that sort of TypeScript linting. I am working towards putting this all into a new named package, IPLD schema. So currently it's IPLD-schema in NPM, but I want to have it at IPLD/schema and bundle it all into the same package and have these utilities that you can pick out. And one of the things I'm doing is updating the validator to be a transformer type of transform and validate. So it's a little bit like the layering in IPLD prime, where you pass just a JavaScript object through, you mush it with a schema, and either it comes out, it doesn't come out, in which case it hasn't validated, or it comes out potentially transformed according to the validator. So you have this, you end up with this representation and typed layer version of things, and then you can do the reverse operation where you say, this is my typed version, give me the representation version. And then you can do things like take your tuple structs and have arrays come out as objects that have got the right names, which would be quite nice. So I've been working on that. That's not a high priority, so sort of it becomes a sort of something that I'm doing to get my head out of Go and do some JavaScript again. So I'll be working on that. The other two things that are mainly discussion-y, there's a CRD v2 proposal in the IPFS specs repo that we're talking about that adds a metadata portion at the end of the CID in the form of sort of a second CID. So two together, and you can use that second one for things like context for the CID. So here's what I'm linking to, and let me tell you a bit about it, so that you can carry over context through links. Interesting discussion there, and I've had some more thoughts since the last time I posted there, so need to go and put my head in there again today. And then lastly, Mohsin's been working on Amend, and we've been having some very fruitful discussions in there about where it fits in the stack and what the goals of it are. So there's a little bit of, it's chopping and changing where this thing's fitting and how it's working. But that seems to be a fruitful discussion, and Mohsin's really learning about the design goals of the stack and getting in deep and excited about it. So that's very good. So that's, I think, my main items, and I think Move is next.
Yep. So I haven't been super busy compared to Rob, but I've been making some more progress on the IPLD gateway. So I'm actually in the process of expanding on some experiments I did initially to get a URL parser and serializer in JavaScript for IPLD URLs, which includes the fancy parameters thingy. And once I've got an initial version of that, I'm going to try to integrate it into JS IPFS fetch and just kind of show what it could look like to have a gateway that speaks IPLD URLs, so that we could also start filling out the IP for it more. Outside of that, I've been catching up on all the WebAssembly discussions that I've had, rewatching all of the recordings from the IPFS thing. So for folks that are into figuring it out, IPFS thing 2022. Wow.
No.
Oh, hello.
Yeah, you're back.
Seems my internet died for a bit. Did you hear me talking about YouTube?
Talking about IPFS thing videos.
Yeah, so you can look up all the WASM stuff on YouTube. I'm looking through it. There's also the discussion that happened last week, which has yielded some useful directions. So I'm going to try to understand the space a bit more and see if we can find out just a way to get a tight integration with all the IPLD stuff and all the WebAssembly stuff in the ecosystem. I'm also working on converting a bunch of IPLD stuff to ECMAScript modules. So I've kind of like actually worked with the build tools that were proposed. So that what this is going to do is it's going to get rid of a bunch of legacy build tooling. We're going to be using this thing called Agear. I don't know how to pronounce it, but it kind of like makes it easier to configure JavaScript build stuff. Formats to start, and that might break a bunch of stuff. It might not. And then the goal is to migrate this to all of the JavaScript IPLD things so that we can have like a more unified build process. So creating new modules and using modules will be more consistent overall. Lastly, I've been talking about probably
I've also been going through the IPLD thing videos. They've been quite good to watch, but I have to watch most of them on like 1.5 or 1.75 speed.
I think this is true generally. I think 2x speed is like how videos are meant to be watched. Otherwise,
really 2x, yeah. Yeah.
Someone's talking too slow. Like, yeah, either someone's talking too quickly in person, or they're not letting it sink in. If you're not like,
yeah, I'm finding that faster when they're content that I'm not that interested in, and like I've got to slow this down for things that are relevant to me. So sorry, Mo, we were just talking about IPFS.
Yeah. Yeah, sorry for my random disconnections. This is what happens when you have a duopoly of ISP entry. It sucks. Something. Anyways, so the Filecoin grant giver folks were like, hey, maybe this polytree standard could be done with Rust instead of Go to start. And so the question is, how feasible is that? What is the state of IPLD in Rust, in particular with reference to ADLs, and also how it could integrate with the FVM? So I'm going to be researching about that today because I haven't dug too far in IPLD Rust. It seems like it's basically just like mats. So yeah, pointers would be helpful, but I'm probably going to read source code. Yeah,
I think I can answer that one for you. ADLs don't exist in Rust unless you count my WebAssembly code that's written in Rust as Rust IPLD, and then you can use that. Oh, so close.
Oh, gone again.
Yeah, I don't know if all of there were a lot of talks around some of the IPLD stuff at the IPFS thing. I think they're basically all up there. There were some more like informal discussions. I'm not sure if they made it there. I'll have to see what videos. I think some of the videos that were like a little more informal didn't get posted, but I'll have to check on that.
Oh my God. Back? Yeah, I'm back. Sorry. This is, yeah, I'm paying $200 a month for this. Anyways, oh no.
Okay. Dean, maybe you should go and do yours, and we'll loop back for anything.
I will do mine in the meanwhile. Okay, I guess start with this Unix FS thing. So following up on what Rod mentioned. Oh, should I pause? We have a person back? No. Okay. All right. Following up on what Rod mentioned. Yeah, Unix FS implementations. We sort of our specs and test fixtures are insufficient, and implementing Unix FS is not the easiest. The flexibility gives you like a lot of room to do all sorts of things and miss some edge cases. I found some bugs in our second Go implementation of Unix FS, which is the ADL one, the one that uses the IPLD prime ADL interfaces. I guess we'll call it, which is Go Unix FS node. Their IRO, which is implementing this in Rust for their IPFS implementation. There's probably a good opportunity here to try and like collect the test fixtures that they're using and try and sort of work together and do some reviewing on specs things to make sure that these are done correctly. I suspect, especially because I suspect the Rust implementation is people will be happier to include via FFI than the Go one, which means it might end up in more places. And so we should really make sure that that thing is correct, and do what we can to help Friedel and Co out there. I guess that's my pitch for that, is noticing that, you know, we've already found a few bugs in there just recently, and this thing is a whole bunch of years old. This WebAssembly codec thing, got some feedback about people about using the IEEE floats as the floats and only having one instead of positive and negative. Seems reasonable. This does mean this is sort of the one way in which the spec will not cover the data model, but I think that's fine. As soon as people start wanting to use really big floats, we can talk about it. We can make a WAC v2. But until then, it doesn't seem like that's something people have been clamoring for. So I'm not going to cry too much about it. Yeah, I have a question there. I guess I'll just raise it now. People can answer later. Which is anything other than my Bencode codec implementation putting non-UTF-8 characters into strings? Because I feel like a lot of our codec implementations seem to reject putting a lot of our implementations of things that I know about already, at least at the spec level, say that they should not have non-UTF-8 things in strings, but I don't know what actually is occurring in the real world.
Because it's so easy in Go, but it's so painful in other languages, particularly JavaScript and Rust. You can do these things, but you end up having to special case just these things to make them hard.
I guess what I mean is, like, as far as I can tell, everyone's specs assume, like, the DAG CBOR and JSON and even DAG PB specs, I think, assume that the strings are UTF-8 things. And there's like some ancient comments in some of the Go Unix FS code that's like, this is UTF-8, but I don't know if anyone ever abided by it because it was a string comment in some code written 6 years ago.
The only place where this has really come up as a concern is Filecoin chain data. There was a field for the first year of Filecoin, this label field that was used as just bytes, and it was encoded as a string in a DAG CBOR string, and that's completely unreadable if you were to load that block in JavaScript. So it's just lost data. And I was coming up with strategies for sort of preserving the bytes of strings through the codec so that you could access them if you needed them later on. But thankfully that got fixed in a FIP, I think it was late last year, and just changed to bytes, like it should have been the first place. But there's that one place and there's a lot of data out there with that, and it has been painful. And I think one of the other reasons it's changed is for the FVM stuff, is to get that all sorted out so that we don't have to futz about in Rust. So
do people have like Unix FS files with file names that are not UTF-8, even though the comment from 6 years ago says they're supposed to be?
It's a possibility, but I can't say I've seen issues that would flag that. And if people are sticking to Go, like the Go implementations, then they're probably fine. But as soon as they start to want to traverse through different implementations, and maybe once IRO starts getting going, unless they bake in support for bytes equals strings, and vice versa, then they might find some of these edge cases.
So Eric, what were you going to say? You had something?
We don't know, right?
I don't know.
I would be absolutely shocked if there wasn't wild data out there in the aptly named wild. Like, as you correctly observed, the comment about this field should be UTF-8 is a comment in the protobuf headers from like closer to a decade ago than not. There has never, to my knowledge, been any code in prod anywhere ever checking it. So yeah, there's probably strange data out there, but just I can't imagine that there isn't.
To some extent, I'm asking because I'm wondering if, like, even though I'm just following the data model things, is maybe the Bencode thing, like, am I rocking the boat by making a codec that's like explicitly, that will definitely end up putting bytes in string fields, because that's how the Bencode format kind of works unless I make the codec do something different.
I think if it's explicit at the codec layer, then that's sort of fine, because every language has a way of dealing with this. It's just, it gets really awkward. It's just when we pass it from above the codec layer, and you say to the data model, here's this thing I'm calling a string, but it's actually just arbitrary bytes. That's when it starts to be a problem. But if it can come out of the codec and say, this maybe not a string, then that would be nice.
Okay, cool. I guess I'll put up the, do I even have a, let me see if I already have that up. I forget. If I already put up the Bencode codec or not. I did. All right, I'll just ping some more folks for reviews on it. Or fill it out more if it needs to be. Yeah, right. I will ping some folks for review on the Bencode codec spec. And we can chat about what would have been, what's the better thing to do there. I think some of the CIDV2 stuff is sort of interesting. I've been, we can talk more about it later if there's time, but it seems a lot of this is about like signaling and where does signaling live and where is it appropriate and what types of signaling make sense inside of a CID thing. And so it seems reasonable that we're talking about this at the same time people are talking about what's it called? At the same time people are talking about, the IPLD URI scheme, things like that. I'm also in the middle of writing up a couple of, docs post things of like, I guess an opinionated view on some of this. In particular, sort of the combination of like what I would like IPLD and IPFS to be able to do, what that means for having IPLD and URI schemes and things like that, and what this means in terms of the whole of like having large blocks. If we have time, I'm sort of curious what people think about large blocks related things. I'll dump some links in the meeting notes, but if anyone reads them, note that they are very, very work in progress. So any comments and feedback's appreciated as this moves along. And that's all I got for now. Yeah, we'll see. Yeah.
Eric, did you want to put anything in, or you want to skip over?
I have mostly been here to lurk and see what people are up to. I am shifting what I'm focusing on with much of my time going forward because I'm working on a new project and trying to build a team for that project. It is a downstream consumer of IPLD, so I still intend to be around very frequently indeed. I would be very disappointed if a bunch of this technology wasn't highly used and supported, and I'm going to still be using it. So I guess I'll still certainly be supporting it as well. A project about computing and hashing, and I won't talk about it too much beyond that. But and because WASM is popular here, I'll disclaim, think less WASM and more like dealing with the reality of programs, especially on Linux. But anyway, not for this meeting. I don't have a ton of other IPLD related stuff. I guess I'll confess that I did a little like personal R&D day recently and discovered that Tree Sitter exists. And I don't know if you folks have heard of this, but I want to just like shout out that it's freaking amazing. It's a tool for building grammars, and it is the best tool for building grammars I've ever. It's incredible. I'm just like gobsmacked by how good it is. I won't say why I was looking into that either. Skunk works. Possibly nothing will ever come of it, but it is a lot easier to write parser grammars with this tool than anything else I've ever used, including Rod. I remember Peg.js being amazing because when you used it, it looked good and I understood it was. This is in that territory, but like similar, possibly better. It's incredible. And I want the Prolly trees thing. I'll have to tell Mo of this in text chat since their internet's cheated on them. But my desire for big trees that are sharded and give me maps and are sorted is high. I would really be way more excited about using those for some applications than I would be about, say, HAMPs. The random order thing in HAMPs is just like, it's fine, but sorted would be a lot nicer. And I guess I'll relay maybe a little news from other folks. There are people working on DataLark, these StarLark bindings on and off. So there's code being pushed into that GitHub repo still. And it's kind of going along. We're trying to figure out where to go with some of it. There's a bunch of basic binding work done that you can use if you're not going to use any advanced schemas or like any fancy features at all. You can just, it's already done. But we're working on how to use schemas as part of a way to make things syntactically more easy and fun and try to have like a DSL for wrangling data over there. And that's a more interesting process and kind of evolving. So I just think that's cool and want people to know about it if it hasn't been mentioned in a while. Trying to figure out what the right amount of do what I mean is in various data wrangling interfaces is kind of like the perennial question, and we're exploring it again through a different lens with that project. No other big news.
Okay. So I think there's 3 topics that we can put in the notes afterwards. One of them we didn't go into here that maybe we should is the CIDV2 stuff. Yeah, so Eric, I don't know if you've been following any of this stuff. The proposal is to smash 2 CIDs together and have the first one be the link and the second one be what you put under the collective idea of context. So, but it turns out that that's quite broad, and it ends up being a largely signaling, but also genuine context. Like, here's this thing I need to pass on as I traverse these links that I don't have a good way to pass on otherwise. I suspect what it'll end up being used for is very heavily as signaling, just more about what this data is and where it fits into the stack. And so one of the challenges with it is since we're essentially having, like, the link is fine, the first, the CIDV one is fine, but the second thing, if we're still overloading multi-codec and multi-hash, we need to, if we're going to do that, maybe we need to have a discussion about what multi-codec is in that context, because maybe it's something different, and maybe the boundaries of that concept are different when you come to that second part. And that's already come up in the initial draft of the spec itself. Came from the lurk perspective, the compute over data perspective, where they really want to pass along this signaling thing where they've got these schemas for data that they really want to attach from when they're traversing links, and they can't. And they want, initially their request was, we want to be able to use multi-codec for this in CIDV1, but we don't have enough numbers. We want to have arbitrary size variants as multi-codecs so that we can have millions of these numbers to pass on. So they have these little, using the number as a signal. But the idea of being able to fit it into a second CID comes up. It's like, we can put anything in it as an identity multi-hash. But then what is the codec there? And anyway, so that seems like something that we should look at very more carefully in that spec. Anyone else want to talk about?
Yeah, I guess I put up in that issue like a couple, like, sort of, I wanted to see more for these things of like alternative proposals explored and ramifications of what happens everywhere when we choose one of them. Because like CID is like very low down the set of specs. One I didn't add there, but is like something I think is a little bit interesting is like, if I understand correctly, we've seen a few times, and I don't know enough about the lurk case to know if this is one, if this seems similar, but we've seen cases where the structure of data is like very rigid, and the hashing is very rigid, and then that starts to cause problems. So the one I'm thinking of is like some of like the binary Merkle trees, like the COMP stuff or whatever, where you don't know, you sort of have to know ahead of time with an external signal how deep the tree is. And to some extent, it would have been nice if I could have had like a codec parameter. So it could have been like codec binary Merkle tree, you know, parameter size of binary Merkle tree, and then the data. And I feel like maybe if you had that, then you would just be in the same scenario we normally are, where like we're talking about people wanting to, you know, what type of typing are they trying to throw in the data? Like, are they trying to use nominative typing inside of CIDs, which seems probably like not the point, because it's generally more about structural typing. Or is it something else? It's also maybe worth flagging things like people have made comments, I think, especially more recently, about like, are codecs just like a subtype of a subset of the things that ADLs describe? Because ADLs describe mappings of data model to data model, and codecs are just bytes to data model, and bytes are part of the data model, so codecs are a type of ADL. And that's true, but like, codecs also have this privilege of having a specific spot for signaling that people sometimes like, because they know where a spot is. And generally speaking, across the various IPLD things, the tooling that we've given people hasn't given them other spots to put in signals. So they all are like, ooh, codec, oh, ooh, CID, that's where the signal should live. Because I don't think they have any other options. And so it may be worth sort of thinking about this in the perspective of like, why is the codec belong in there and not the ADL, or the other way? Like basically, like what signal makes sense inside of the CID and why? We don't want to. I don't think we want to. It's not like our style to like tell people don't do this because it's a bad idea and like stop them from doing it. Like our style is more like give them the information they need to know to understand why this is a terrible idea, and then let them go ahead as long as they're not getting in anyone's way.
We do have a gate though, which is the multi-codec table, and
Yeah.
that's where these discussions become hard, because we end up having to do some amount of policing, and it's an awkward kind of policing, because we're at that point of saying, look, we do have some criteria for getting into this table. So we want to have a discussion with you and maybe gently talk you out of the thing that you're proposing doing. But at the end of the day, we probably shouldn't be gatekeeping too hard. But what is that too hard? You know, there is a gate there, but what is it, just open? So it's not open, but so this CID v2 does open that even more. And I think what we would see is we'd come back to that discussion of, well, it's a multi-codec. I want to use multi-codec for signaling. And then we're saying, no, that's not what it's for. But maybe in that second spot, it's not a multi-codec. Maybe it's a signal or something else that could be a multi-codec, or it could be something else. And maybe we can put them in the table. But maybe when you call it that thing, then we don't gatekeep so strongly, because it's like, well, you want to do that thing? It's a signal, great. Put the signal there.
Yeah, I mean, if we had, I guess maybe the side thing, and again, I don't know whether this needs to be a full CID thing or not. Like, if we had like a parameter in there, right? Like if it was the same way that multi-hash has like a digest, right? Like if we had a parameter for the codec, in theory, we could have a codec that was just called like YOLO, and then you put a string in there, and then that's the name of your codex, so you don't have to like reserve a number in the table. And it starts looking a little bit like how libp2p operates, where like you can choose your protocol name, and you should just make sure you're not colliding with other people unless you know what you're doing. I think to some extent they'll probably end up thinking about the same problem too. I know that when they get time to think more about how to improve like protocol select or the thing that replaces multi-stream, I think they're interested in like how they can save a few bytes for common protocols by swapping the names with numbers, but still preserve the names thing that makes people not have to use the table. But sometimes it's not even about the table, right? It's about like other people need to support your data structure. Like I can't move my data structures around through an IPFS HTTP gateway, even exporting them as car files, if you don't understand the IPLD codec I've given you. Like, it's not an option I have. And if we start adding support for ADLs, the same thing happens, whether it's a string, as it is right now, or a number. Like you still need the code, which is where the people start getting into like WebAssembly land, where they're like, what if I could, if I could just pull from like the global universe registry my data, right, and then execute it in a sandbox. Like that's where that desire comes from, is to resolve that part of the equation. Yeah, and I'd like to see more examples. Like I was hoping, and I guess we can ping some folks like Michael to get where they're coming from, because I have a suspicion that the types of signaling that he's looking for and the types of signaling the Lurk folks are looking for is not the same.
No.
And understanding what's going on there will probably help us learn more about what this needs to look like. Because I guess one of my concerns is like, everyone's like, oh, there should be two things, mine and yours, right? Or the regular one and the one I need for my format. And like I say that because I have a special thing in mind. I want an A at the end. And like Eric comes by and he's like, yep, sounds like there's a good idea. There should be the standard one and there should be an extra one at the end that's like for E for Eric. And then we're both like, yep, 1+1. And then we start using it. We're like, wait a minute, how come you're not using mine? I thought we were supposed to do it my way. Why are you doing it your way?
Yeah, and you can already see that problem in the fact that this was birthed from Michael, but then it was taken to a spec by Lurk, and even in that process, it became something a bit different. So yeah, I agree. We do need to see. So I'd like Michael to nominate someone, maybe Irakli, to come and tell us about what this thing would be used for and how, and because I do suspect some of it is very much that problem of we want to do this multiplicity of things and we're stuck by not being able to signal, and UCANs I think come into play here as the big thing in the big elephant in the room. Maybe it's not even an elephant, but it's in the room, and they want to do more stuff with UCANs and CIDs. And then we get to the discussion of should UCAN be a codec or just DAG-SIB or with some other signaling. I think that's the tricky bit.
Yeah, and including things like, even things like signature verification. Like sometimes people want to put signature verification, and again, because the signal is there, they want to put it in the codec because they're like, well, then I'll know it works, and I'll know it works with this type of tooling that when it loads, the data is all the signatures are all verified. You're like, but is that what you wanted, or did you want to just like load the data, and then you want something else to be doing the signature verification for you? I don't know, it sort of depends, right? On how you're using all these things.
It does, but we are trying to support an ecosystem of that are doing things that we wouldn't do ourselves.
Yep.
And getting past that problem of we want the data to pass through all the systems with the DAG integrity maintained throughout. That seems like a top line problem, and if we don't provide people tools to do the things that they want to do that we may not want them to do, but they want to do anyway, then we're going to end up with a lot of codecs that can't pass through our system. So maybe this is simply just an escape hatch for, hey, you know, just use the codecs you have, put it in the CID like normal, but you can put extra stuff in there that does your thing, and it'll still pass through the systems, and then your thing will be maintained all the way through, and then you'll get it out the other end and be able to do your custom thing with it. Maybe that's all this is an exercise in doing.
Yeah, although again, if you just need a little more, if you need a little more signal on things that are sort of actually data, then maybe that's just, instead of an extra multi-hash at the end, it's just an extra optional field on the codec, right? Where I can be like, nominative typing for my application parameter, because I've decided I want nominative typing and I don't like you, right?
And I think we should push the discussion in that issue into why a multi-codec plus multi-hash. Do we really need that? Because then we get to the problem of it's still called a multi-codec and a multi-hash. But if you're not actually going to use either of those things for what they're called, then maybe that shouldn't be what we're doing. Because I can imagine lots of situations where people are just saying, oh, all I want is a signal, so I'm going to put a number in there. I'm going to use the multi-codec field, but then I've got this multi-hash thing, and it's just going to be 3 zeros just because it's a null multi-hash. So we're going to end up with a number and 3 zeros. And if that's what we end up with CID-v2, it's just the CID-v1, a number and 3 zeros, then that's a bit of a failure.
Yeah, and the ramifications of this, like understanding the alternatives, so that even everyone agrees we found the new answer, CID-v2, here it is, it'll save the day. There's going to be a while before it gets rolled out in a lot of places, and helping people understand, like, do I want to try using the CID-v2 thing, or like, do I want to just stick with CID-v1 because it'll give me, and I'll just get around this some, I'll put my signals in a different place, right?
Yep.
I feel like that kind of thing seems like, again, interesting for us to explore and understand, right? Like, for example, I could see like, maybe this makes a lot of sense for Lurk. What Lurk is doing is very different from what basically anyone else is doing around this stuff. And so if they wanted to mandate, like, no, we're waiting around for people to update and take this new stuff, and you need that to interoperate with what we're doing anyway, maybe that makes sense for them. Whereas maybe for tagging UCANs, it makes less sense. I don't know.
Okay, but I think Lurk is different, but it's also similar to all the non-Go use cases. I think we are hitting a problem where if we come to all this stack through the lens of Go and our Go stack, so ADLs and the nice things nicely fitting together, if you come from a perspective of not having those things, then you start wanting, your concerns line up differently. And we're seeing that in the JavaScript world, which is why we're seeing it come from Michael and UCAN people. They don't have that same stack, and they're viewing things differently, and they're saying, well, we're just going to have lots of codecs. And they're like, oh, well, maybe that's not a great idea, but we want other things. So, and I think, and the Rust, and well, I mean, Lurk is not even Rust really, if you want to define it purely, but Lurk is in that world of, they've got their own stack, and it's like the basics of it. And we may even see things similarly come out of what Iro's doing and sort of moving away from the core Go land. So maybe this is just a symptom of not having a full IPLD stack.
Yeah, I think that's part of the thing to explore, is understand like where some of the boundaries are. And some of it I think is also making it like easy for people. Like one thing I noticed when I was doing some of the WebAssembly IPLD stuff was that, or just trying to implement or even, I guess even aside from the WebAssembly stuff, just trying to implement a new codec in ADL for BitTorrent things was like, it wasn't obvious where to draw the lines. Between like which logic lived where. And like, while I could just decide on one, it felt like that like mental burden of needing to think about it, I feel like can like throw people off. And so maybe like, yeah, whether it's this, how the different layers of, I guess, lenses, or the different layers of like these interpret as this layers that we keep throwing on stuff. helping people understand when to use the different sets of tools and like what they're for.
Okay.
Looks like we're getting late, so I don't want to hold people.
Yeah, I need to go. Right, so cool. Well, I'll stop the YouTube, and thanks everyone for tuning in. If you did.